Mode.
Hello, everyone, and welcome back to vBrownbag US on this fine Wednesday night. A few show notes before we get started. If you'd like to follow us on Twitter, we're at vBrownbag, or at vBrownbagLatam, or at vBrownbagEMEA, depending on what part of the world you're coming to us from. If you have any questions or you just want to mention us on Twitter, feel free to use hashtag vBrownbag. Make sure you check out our other shows. We have one in the APAC region every other Thursday at 9 p.m. NZST, and I've actually got a whole Cisco ACI series going on that one right now. Um, the EMEA broadcasts are Tuesdays, 7 p.m. BST, Latin America, Thursdays, 7 p.m. Pacific, and of course the US, Wednesdays, 7:30 Central. So tonight our guest is the one and only Andy Banta at Andy Banta on Twitter. And I'm your host tonight, Lauren Malhoit at Malhoit on Twitter. Andy, thanks so much for joining us. I'm going to pass it on to you. And at the same time, how are you doing tonight?
I'm doing great. Thanks, Lauren.
Awesome.
Looking forward to doing this.
Yeah, I'm looking forward to watching. So yeah, take it away. You should have the presenter stick now.
I do. And so I'm going to give just a quick technical overview of vSphere Virtual Volumes tonight. Want to thank Rollins and Rivera and Cormac Hogan. They gave me permission to steal an awful lot of their slide content to put this together. So if you've seen any of this before, you probably saw it from one of them. This is me. I'm currently a storage janitor at SolidFire, working with Tech Solutions Group, and in previous life I was at VMware doing ISPC stuff. As Lauren mentioned, my Twitter handle is at Andy Banta. So I wanted to get into some of the general ideas of why vVols came about. Previously, or in this case, it's today's infrastructure. The idea is that you would have a storage administrator that would set aside volume or LUNs on your storage array, and all the services would be tied to that storage array, and the management of the storage array was very vendor specific. The goal that VMware was trying to come up with vVols was to allow the consumer of the storage to have more control over it. So wanted the consumer of the storage to be able to carve it up as they wanted, have better control over like quality of service and the abilities that were associated with it, like encryption, deduplication, that type of thing. And it wanted the management of this to all be consistent, no matter what the storage vendor was. So the idea was to allow the app consumer to put things together quickly, not waste a lot of resources, have the QoS and capability aspects handled, managed automatically, and make it fairly simple to actually make the changes. So VMware started talking to some storage vendors and came up with this idea of how can we do this. They wanted some way that a storage vendor could actually know what a virtual disk looked like on the storage. Right now with VMFS, the storage, the VM is represented by VMDKs and a handful of other files that are actually hidden inside of VMFS. The VMFS is created by vSphere, and the storage vendors really don't have any visibility into what's inside of VMFS or how to manage anything in it. The other problem that you run into with this is that you have to set up all of your storage capabilities at the VMFS level. There's not any way to actually, come up with individual ideas or individual capabilities or like QoS and whatever for the individual VMs. You have to do it at data store level. It added the concept of storage policy-based management. This actually is a way that vSphere communicates with the storage array to come up with the capabilities or align the requirements of the VM with the capabilities of the storage array. They also wanted to make sure that they weren't coming up with a completely different storage protocol. They largely succeeded in that. It works with iSCSI or FC or NFS currently. It actually is fairly heavyweight still, even though it's using the underlying protocols to do what it needs to do. But the idea was that if it was a completely new storage protocol, you would potentially break some of the capabilities that other storage vendors already had, and nobody wants to go out and spend the qualification effort to use a completely new storage protocol. And VMware made sure that they actually had buy-in from all the major storage vendors, and as of vSphere 6, it is actually included in vSphere. So here's a top-level architecture view. We'll start in the upper left-hand corner where you have a vSphere administrator who decides what type of policies they run for a VM and assigns those different policies to various different VMs. The vSphere, the virtual volumes or VVols, will take a look at what's available in terms of capabilities from the storage system and make sure that those VMs actually get the policies that they need, and they'll actually get put into a virtual data store on the storage system. Aligning the capabilities, creating the VMs, all the management of the VMs actually happens in the control path. It's way over on the right side of the screen and goes through what's called a boss provider. I'll get into more details there. And the boss provider tells the storage system, hey, here's the vVols we need, and the storage system is actually going to create the vVols individually for that VM. So from the storage admin side, they have the ability to decide what capacity is going to be available for vVols, what the access methods are, and then basically what the published capabilities are for snapshot replication, QoS, etc. So I'm going to cover what some of the objects are for vVols during this talk. Basically, the objects of vVols come with our virtual volumes, storage containers, protocol endpoints, and the boss provider. It's the VMware's very long name. It shrinks down to boss provider. You never actually need to know that name again. And some of the concepts associated with vVols, the out-of-band management, how the bindings work, what the policy-based management is, and then getting into a few of the VMware vVol capabilities. So I can't help with this analogy of kind of thinking of vVols like ordering stuff off Amazon. So the idea of a vVol is it's going to be a virtual disk or a virtual volume that you need for something, for a VM, or whatever. It's just stuff. It's you go out and you say, hey, I want a vVol. It's kind of like going on Amazon and saying, hey, I want a pink fuzzy vest. So there are various different types of virtual volumes. Right now, VMware has defined 5 of them. There's a config vVol, which holds what you normally see if you've gone in and browsed a data store, looked at a VM. There's things like .vmx files and log files and NVRAM files, the stuff that you need to actually define what the VM is. And then there's the data VM, or data vVols. That's actually the VM decays that are associated with it. If you actually create snapshots of VM decays, those are also data vVols. Then there's the mem vVols, and those are actually memory snapshots. So if you either suspend a VM or if you take a snapshot of a running VM, the mem vVol will be where the memory image is for that snapshot. And then just like you have on the current vSphere, there's actually a swap. A swap vVol is created that you would normally see as the .swp file on vSphere today, which is the swap file for that VM that VMware will use to push out contents of memory if it actually becomes starved for memory. So,
Andy, a quick question there.
Yes.
So,
Yes.
Are those different types of virtual volumes, are they actually different? I mean, are they optimized for those specific things, or is a config vVol just something that contains those files?
So I'll get into a little bit of the implementation here. So a config vVol actually has a little tiny file system on it, so it can contain multiple files. If you go browse it like it's in a data store, you'll actually see the individual files. So config vVol actually is a little tiny file system itself. It's always 4 gigs, so it's not like there's a whole lot of stuff stored in it. The data VM or data vVols are the ones that you can actually do the most tuning on in terms of what you want your for vVols or other capabilities. The mem and the swap don't typically have a whole lot of tunables on what you can do. They would just additional ways of telling the storage, hey, I need this fixed size of vVol for this purpose. And in the case of like a memory snapshot, you are pretty sure that it will be written once contiguously and read one or more times contiguously. And the swap, there's just going to be a memory image, and that it will be written pretty randomly. I think they separated out mem and swap just to give the storage vendors a hint of what's going on. But those are the only reasons why they're separated out that way. And while they specify in other vendor specific, I really don't know of anybody who has other vVols.
Gotcha. Awesome. Thank you.
Okay. So vVols also introduces the concept of a storage container, and a storage container is actually where all the stuff lives. So in my Amazon ordering model, a storage container would be like your house, and all the vVols that you order up end up in your house somewhere, and they represent pieces of VMs. So it's not the best graphic, but here you are with your storage container with the VMs occupying it. The idea of a storage container is that it's a logical grouping of the virtual volumes that you want to be associated together. The storage containers are actually created by a storage administrator, and the storage administrator will set up what the physical capacity of storage is. Like in SolidFire's case, the capacity of a storage container is actually the same as the capacity of the array. It's a way to actually separate out the VMs that might have certain storage needs and requirements. And the storage arrays have to actually specify at least one storage container, and the maximum depends on the array. I'll get into why storage containers are there in a little bit more in future slides. So the difference between a storage container and a LUN is the storage container is based on the size of the array capacity. Storage containers aren't necessarily fixed size. Certain vendors might have them fixed size, but there's something that can be configured in any way that the storage vendor wants. And there are ways of actually grouping VMs or virtual volumes to have certain homogeneous capabilities that you want to be able to play with. And in SolidFire, it's simply an attribute of the vVol. Compare this to the typical LUN that you get with typical block storage, which is fixed, a fixed size. You need to put a VMFS on it unless you're actually doing something like directly mapping it to a VM, which I wasn't going to get into a whole lot. You can only, all the VMs in that VMFS actually have all of the same capabilities. There's no way to separate them out. And the LUN itself is actually managed entirely in band, whereas the storage containers are managed out of band. So the reason that we actually have a storage container concept with vVols is to allow the different administrators to have different views of what's going on. So the storage container is set up by your storage admin. It would be just a logical collection of what's available on that storage array. You could have more than one, obviously. And what it appears to for a VM administrator is a data store. And that's, VMware did this because there's an awful lot of things in vSphere that count on being able to do things at a data store level, setting up things like storage, IOC, being able to do replication, being able to group things together in a certain way. And I'll just mention that with SolidFire is creating storage containers. They're actually tied to an account, so you can actually use it as, if you're a multi-tenant customer, you can actually use the storage container to identify your tenants. Here's a comparison of what the two views would be. So on the left side, we actually have what a vSphere admin would see with the various different components of VM inside a storage container, and it looks just the same as it does now. And currently with vSphere, where if you go in and you do the data browser, it will show you the VMDKs, it will show you the config files, show you everything else. If you take a look at the storage admin view on the right side, you'll see that it's the vVols are actually individual items and to be managed that way. So the storage admin has the ability to go in and tweak the QoS on any one of these, enable them or disable them. And so just a couple questions that typically come up around this time is, are they required in vSphere 6? And the answer is no, they're not required. You can certainly use VMFS just like you always have. And in fact, since vVols actually requires being able to talk to vCenter, if you run a virtualized vCenter, you can't actually have your vCenter on vVols. You actually need to have your vCenter on a VMFS to allow it to actually configure the vVols for other consumers. How does this help in performance and capacity management? Well, it helps a couple different ways. It allows the storage administrator to actually set up different performance capability, different performance specs for each vVol. And it also means that you don't actually need to carve out a big LUN for your VMFS that might actually end up with wasted space. The vVols are actually carved out individually when they're created, and your storage array should be smart enough to not actually consume any more space than just that vVol needs when it's created. And do I lose anything with virtual volumes? As I mentioned, you end up with needing a few applications that actually need to stay in VMFS currently, just to give the out-of-band management. So you lose the ability to have completely in-band management with these vVols.
So does it matter what the underlying storage is? Could it be a vSAN even?
That's a question for VMware. I believe that there's actually a concept of using vVols on top of vSAN, but that's very specifically a VMware question. This vVols was actually created as a way for VMware to do more stuff, partner with storage vendors a little bit more. And since VMware is now their own storage vendor as well, I'm sure that there's some sort of way that you can actually use vVols with vSAN, but it's not something that outside storage vendors are going to have a lot of visibility into right now. I don't know of any announcements that have been made about that. People from VMware might.
Sure, that makes sense.
Okay. So now to dig into the underpinnings of this a little bit. So continuing with the Amazon analogy, protocol endpoints is actually how you get your stuff. So a protocol endpoint is, if you take the name literally, it's the point on storage where vSphere will connect to it. So it would be an iSCSI target or a fiber channel target or an NFS mount point. And this is how vVols are presented to vSphere. So the idea here is that you can have all sorts of vVols and they all end up going through one protocol endpoint. It's different than the concept of one VMFS that actually goes through a target or LUN or NFS mount currently. So the protocol endpoints allow access between ESX hosts and storage arrays. There'll be something that will be visible on your storage fabric. So you'll be able to go out and like with iSCSI, if you do a send targets, it'll actually show a protocol endpoint. They're created by storage administrators, and by storage administrators, this could also mean that it's created by a storage system. So in SolidFire's case, the storage administrator actually doesn't need to go out and create new protocol endpoints the storage system actually will figure out how many protocol endpoints are needed and create them. The protocol endpoints were a way of maintaining using the same storage protocols as we currently do. So all of the storage protocols that currently work with vSphere will work with vVols and protocol endpoints as well. And I think I touched on this a little bit earlier. One of the advantages of this is that if storage vendors have built any of their secret sauce into how the storage protocols work, they haven't lost any of that. So any of the multi-pathing policies and practices that you currently have with ESX and a storage vendor should also work even with vVols. So, pardon me. There's a couple different ways today of how you actually contact your storage. Either there's NFS mount points or IP targets that you would connect to for fiber channel or SCSI. And today, a data store actually represents a couple different things. So a data store represents the target or mount point where your VMFS or in NFS case, your NFS file system lives. And it also sets up what's essentially the equivalent of a storage container with vVols. So it sets aside the data store or the mount point, and when you go in and look at this through vSphere, it will show the data store, which also is tied to that endpoint. The difference between protocol and the difference with vVols is that the Ps no longer have any way of storing anything with them. Actually, if you scan a PE and fiber channel or iSCSI, it'll show up as either a 0 length or a 1 block length file system. You can't actually store anything on it. A big advantage of this is that you won't need as many data stores as you have currently. I know that lots of people right now have to go out and create loads of new data stores every time something expands, or you have to carve out a new run, you have to create a VMFS on it, you have to create a new data store on it. And one of the reasons people also create lots of data stores is that with VMFS, you end up with contention with the VMs that are in that data store, and lots of times you need to actually separate things out so you don't have too many VMs in a single data store to get rid of the VMFS contention. So the way the protocol endpoint is discovered is largely the same way that you actually go out and discover new data stores now. Once the protocol endpoints once vVols has been enabled in the storage system and the administrator has created the protocol endpoints, simply doing a SCSI scan will show up your protocol endpoints. And if it's NFS, it's going to be very similar to the way that you mount NFS today, where you give it an address and a mount point, and it will find the protocol endpoint. So the final piece of vVols is actually the VASA provider. And the VASA provider is the out-of-band management of how you create vVols. So it's kind of like the order page that you currently use with Amazon, where you go in and you tell it, hey, I want to get this type of vVol. I want to create a VM as 3 VMDKs and this QoS and these other policies. The VASA provider sits outside of the data path. Data path would go through a protocol endpoint, while the control path would actually go through a VASA provider. The control path is currently limited to being through IP, TCP/IP, and run through the management network, similar to the way the vCenter talks to ESX hosts. The VASA providers are something that are actually created by the storage array vendors. Both ESX and vCenter talk to these VASA providers. vCenter will contact it to just find out what the basic capabilities are, and then once ESX is actually talking to storage on the array, it will contact the VASA provider itself. The VASA provider actually is bidirectional, so it's the way that vSphere and vCenter get the capabilities that are available with the storage. You can have a single VASA provider that can handle multiple arrays. Again, I'll mention the way that SolidFire handles this is we have a single boss provider that works for a cluster. So if you have multiple SolidFire clusters, you'll have multiple boss providers working on them. And the whole idea of the boss providers is that it's a way of actually handling the Rasa API requests that ESX is documented and sent out. And the boss provider is responsible for like creating and deleting virtual volumes, as well as creating snapshots, creating clones, that type of thing. So getting into some of the concepts now, since we have ESX on one side or vSphere on one side, and we have a handful of protocol endpoints on the other, there needs to be some way of actually making these, connect for each other so you can actually see certain vVols through certain protocol endpoints. So that would be kind of like the distribution facility at your Amazon warehouse or whoever's warehouse, where it decides which vVols actually are going to end up on which trucks. So the idea behind bindings is that ESX will say, hey, I want to be able to access this certain virtual volume, and the storage system is going to take that request, attempt to identify that virtual volume, and tell vSphere, here's how you get to that. So the various different steps that are available would be a bind, which would be vSphere saying, hey, I want to be able to talk to storage. An unbind, which says, I'm no longer interested in talking to storage. You can, hide it from me if you want. And a rebind, which would be a request typically from the boss provider side up to ESX saying, hey, it would really be best if you tried to bind to a different protocol endpoint. So the basic idea is that ESX will send a request for a particular virtual volume, and the storage array through the boson provider will actually return information that says, hey, this is the protocol endpoint that you're going to use to get to that virtual volume, and here's the secondary ID that's used to actually identify it once you get to it. So when ESX talks to that protocol endpoint, it's going to pass along the secondary ID of that vVol, and the storage array will know that vSphere is looking for that vVol that was provided that binding. And the bindings, again, work on all of the protocol, various different storage protocols. And similarly, vSphere will issue an unbind request at the end when it no longer needs the vVol. It wouldn't necessarily be when the VM was destroyed, but it could also just be when the VM is powered off. There's no need to have a binding to a VM that it doesn't need access to anymore. And there we've got the neat little animated arrows. So the way a bind request actually works, step by step, is you have your vSphere connected to a protocol endpoint, and you'll issue a bind request to the boson provider. And the boson provider will do two things. It will return two things. It will return the PE, so vSphere knows which PE to send commands to, and it's going to return the secondary ID. So the secondary ID is actually what's called a subsidiary LUN ID in block protocols. In NFS, it's actually probably just a file name. I'm sorry, I'm not as well versed on NFS defaults. And there you are, secondary LUN ID. So you can actually end up with a many-to-many relationship between vVols and PE. So you can have multiple vSphere hosts that can actually contact the same vVol, and they don't have to be going through the same PE, although they can be. And actually, in a rebind case, you will end up in a situation where vSphere has a binding to a vVol through one PE, and it will ask the storage, hey, I'd like to bind to a different PE. It will maintain that binding until the storage array returns, hey, here's a new binding for you to use. It will make sure the new binding works. So in that case, vSphere will actually have two bindings to the same vVol through 2 PEs before it unbinds the first vVol, or unbinds the vVol through the first PE. I know it's a little bit hard to imagine, but this is the way that vSphere actually makes sure that it has connections to its vVols. And so the way that we actually go on find storage containers, a storage admin on the storage array will set up a storage container, or more than one. Certain capabilities will be assigned to that storage container. Once storage container is found, you'll tell vCenter, I have a VOS provider here that knows about storage containers, and it will go identify the storage containers, and here we are. The storage containers will be created. The capabilities of those storage containers will be associated with them. VOS provider will communicate this back to vCenter, and then the storage or the vSphere admin will actually create the VMs. So here's a quick overview of how to actually provision VMs. The vSphere admin will create VMs, assign a VM policy to it, and a suitable storage container data store will be assigned. So here's a little bit more detail on how you do it. So you actually have a storage array with storage containers that are capable of creating virtual volumes. The storage will present the capabilities of that storage container to the VOS provider. The VOS provider will tell vCenter what the storage capabilities are and present those as storage policies. The vSphere admin, and in this case the user, will choose which storage they are interested in using. A virtual volume will get created through the VOS provider for that particular storage, or actually a handful of virtual volumes for those VMs, or VMs will get created. Virtual disks will get created and make sure that they align with storage policy that you want. And then both administrators, vSphere and storage administrators, can make sure that the policies and capabilities are in compliance. So storage capabilities are actually things that are presented by the storage array. Examples that are shown here on the right side would be like snapshot replication and various different QoS capabilities. They can be offered as depending on what your VM requires. As I mentioned, they're actually advertised through VOSA. And then the VM storage policies are pieces that are assigned to the VMs. And so a VM will say, hey, I need this storage policy, and the storage-based policy management will go find appropriate storage containers and storage for those capabilities. So now we actually get into storage policy-based management. We talk about array capabilities. So the array capabilities are things that the array can do. As I mentioned, the dedupe, encryption, QoS, that type of thing. And the flip side of this will be the vSphere administrator will actually go in and create will create policies for the VMs. And so the policies actually need to be able to match the capabilities. And once the capabilities are met, the STVM will report they are in compliance and say that, hey, you have a good storage capability for the policies your VM requires. So this is just covering a handful of things that the vVols offloads that currently you would need to do through vSphere and would end up being VMFS operations that would go over the wire. So the virtual machine provisioning and deletion, clones, link clones, snapshots, and storage vMotion. Actually, one of the things that we have been talking to VMware about is the possibility of getting rid of the idea of storage vMotion between vVols entirely, and simply saying container, say it's in a different storage container, and not actually have to do any data movement at all. So we'll see what happens there. But the other thing is that you can actually, the vSphere can actually tell VVols to migrate from a VMS to VVols. And if the storage array is capable of doing that, it'll do that without actually needing to do data movement itself.
Hey, Andy?
Yes.
We have one question. If the VASA provider is unavailable, what functionality do you lose? Can you still power on VMs, for example?
Actually, that's one of my canned questions that I had later on, but I'll answer it now. So the answer is that you lose the ability to create, power on, migrate, do a whole lot of other things with VMs. Any VMs that are up and running will continue to stay up and running. Their I/O path is still stable, and they can do everything that they had been able to do. Because of this, VMware actually provides some specs on how to handle HA for your VASA provider. The idea is that you can actually have multiple VASA providers to handle the possibility that one VASA provider has failed. And in a few slides, I'll actually get into how SolidFire handles this.
Cool. So we get VASA redundancy.
Yeah, you get VASA provider redundancy. I did want to touch on snapshots a little bit, since snapshots are actually done in a very different way with vVols than they had been with VMFS. In VMFS, vSphere would create what always appeared as a snapshot file in the data directory. It actually was a review log that said, hey, here's all the things that have happened since the snapshot happened. Here's how you get to the same state that you were previously. The concept is very different now, where you actually, vSphere will actually tell VMware, or tell the storage array, it's time to take a snapshot, and the method of taking that snapshot is entirely dependent on the storage array. You can still do pre-S backups if you're actually doing like a application consistent snapshot. That's still understood. And VMware is very big on making the distinction with snapshots, but there's two different types of snapshots with VVols. There's managed snapshots, and these would be snapshots that you actually do through vCenter or ESX, where you have vCenter tell the storage array, create a snapshot, and in this case, VMware will know that there's that snapshot that exists on the storage array. Contrast this with unmanaged snapshots. These are ones that the storage administrator can take and create a snapshot of a vVol. And in this case, the snapshots are something that the storage administrator can manage, but unless you actually revert to one of them, there's not actually a way to expose those to vSphere. This is just a very brief block diagram of how SolidFire does this. If you're not familiar with the SolidFire architecture at all, it's not going to make a whole lot of sense, but if you touch on it a little, SolidFire is a cluster architecture where we have multiple nodes, and each one of the nodes, there's shared nothing with the nodes, so the nodes are pretty much independent. We have what's known as a cluster master, a thing called CM here in the center. It will be on an available node. And the cluster master itself actually maintains the VASA provider and some of the other management stuff that we do with the protocol endpoints. So the idea here in this case is if the middle node actually went down, the cluster master would migrate to one of the other nodes, and you would still have access to your VASA provider and the ability to connect to the PEs. And in this case, the protocol endpoints are typically put somewhere where they have optimal access to the vVols that they're talking to. But in cases where they don't, the protocol endpoints will actually talk across the nodes to get to the vVol that they need to. So this is getting into the summary section, going through a list of the vSphere features that are supported. supports SPPM, so storage policy-based management. That's not just supported, but it's required to make vVols work. Thin provisioning, link clones, native snapshots, all the protocols, CBRC, vMotion of course works. Storage vMotion works as well, although with storage vMotion, hopefully you won't need storage vMotion as much because you can simply actually move the vVol or the VM from one protocol endpoint to another and end up with the balancing that you might need. DRS is available, long distance vMotion. All of the vVols things will be supported through the vSphere software development kit, so you can actually manage them without having to go through the GUI. Well, I don't know what that is. Horizon View, all of the vRealize operation and automation still works, and the statelessness and host profiles still work as well. So just a quick review of what the motivations were for vVols was separate out the storage management and the VMware management to make use of existing protocols to separate out the concept of data store from logical collections of storage. Better use of available storage. This is both in terms of capacity and throughput. The idea that you don't actually need to have your vSphere go out and write stuff to a VMFS to create a VM. You can actually just tell the vVols POSIT provider to create a VM and it will be there. Less contention between ESX hosts. This is the VMFS contention that you get rid of. The idea is that you don't have any metadata that you need to maintain between multiple ESX hosts, and therefore you end up with less contention. Better use of the storage network, storage network bandwidth. If you don't need to storage vMotion as much stuff, if you don't need to go out and zero fill a VMDK when you create a VM, you don't end up eating up nearly as much storage bandwidth. So the whole idea that VMware was trying to come up with here was that it should provide you better scalability, that you can actually hopefully provision more VMs on the same storage, and better control, so you can actually see your individual VMs from the storage perspective rather than having to manipulate everything through VMFS. And I built this, I mentioned this already, but the motivations were the ease of management, using existing protocols, more scalability, in terms of capacity and SAN bandwidth. So vVols is actually bought into by quite a few storage vendors at this point. You can see a quick view here, and this is not exhaustive. This is simply the big name players that are out there. And now it's open for, well, actually, how do we, here are some of the common questions. So as a storage administrator, you might actually have to configure your POSIT provider to DHA. Some storage vendors actually run the POSIT provider as a VM, so you would need to actually deploy the VM and have it manage the POSIT provider. From SolidFire perspective, all you need to do is tell the cluster that you're going to be using vVols, and the POSIT provider will start up. A storage administrator might also have to create protocol endpoints on the storage array. I'll mention once again that SolidFire, the idea is that if you turn on vVols, the protocol endpoints will be populated and increased and decreased as need requires. And I already answered what happens when we are running without a POSIT provider. So, questions?
I'm not seeing any others right now. Nope, let me check Twitter. Nope, no other questions right now. That was awesome, Andy. Great information.
Good. Good. Uh,
All right. So thanks so much to everyone who came to join us tonight and to those who are downloading it in the future. Thanks to you, Andy, again, Andy Banta at Andy Banta, and we'll see you next week.
okay, and you can also contact me by mailing me at banta@solidfire.com.
Awesome. Thank you so much.
Okay. Thanks, Lauren.
All right.